Espera aí a ver se está. Okay. Good afternoon. Thank you for coming. Thank you for everybody. This is the closing section of a webinar series on the topics of spatial data science. And this section is very special because it is a tribute to a special person, a very special, extraordinary professor and researcher. It is one of the very few highly cited researchers, and in this area, in this school. Of course, I'm referring to José Bioucas-Dias. And to pay this tribute, who better could be chosen than Mário Figueiredo? It doesn't need any presentation, but is also exceptional professor and researcher, and also a highly cited researcher. But on top of that, is a friend of José Bioucas, with whom he shared a great piece of work. It is his testimony that Mário will present to us today. Thank you, Mário. Stage is yours.
Thank you. Thank you all for coming. Thank you all for those who are online. So this is actually a rerun. We had the previous version of this last year, only online, but I decided to do it again now that we can be together at this summer. So this is a sort of in memoriam presentation in the memory of my friend and colleague, José Bioucas-Dias. He became a monitor, so a teaching assistant, and the other one is from '86 when he became a teaching assistant, assistant in the Portuguese language. No, please.
No há som.
Okay, so start again. Apparently. I thought. Okay. Sound okay? Deixa eu pôr assim, tirar o microfone desse. Okay? Can someone online say if they can hear?
Sim, já se ouve, Mário, obrigado.
Okay, so I'm going to start again.
It's not very audible.
Okay, sorry for this. So as I was saying, these are the documents that José signed to become first what was called here a monitor before he finished his master. Is actually the double E degree, and then the other one. And the funny thing about this, deixa eu pôr o teu em mute. Mute o computador. Mute o computador mesmo. That should be okay. Okay. It's still Zoom does not obey that. Yeah, I don't know. Okay, the funny thing, I will continue. Yeah, no. Still. Os outros. Cut the mics of all the other people. Ask everybody to turn off their mics. Did you okay now? No. Yep. 1, 2, 3. Echo, echo. Indeed. Yeah. Yeah. So you can no, but está muted. Está muted. The computador está muted.
Tem que ir lá para fora, né?
Now it should be okay. Okay, yeah. Can you still hear me?
Yes.
Okay.
Obrigado.
Because now it's only sound is here. Okay. Sorry for this technical glitch. So an interesting thing about this document on the left, I don't know if you notice, anyone notices, is one thing that was always very amusing for José. We laughed a lot about this, was the number of different ways in which people wrote his name. So in this official document, it's written as Bioucas. And he had a huge collection of interesting misspellings and misunderstandings of his name. The most fantastic of all was Minhocas. He wrote it down, and he had a paper with all the instances of mispronunciations. Okay. And then he signed, of course, I will cumprirei com lealdade as funções que me são confiadas, which he certainly did. So this is us in 1986. After we finished our EE degree, we spent some months building this equipment, which was used for many years in teaching. I think it's here, yeah, in teaching communications here at IST. So we designed it and built it ourselves with our hands from scratch. It took us what, maybe a year or something like that, maybe 6 months. I don't remember exactly, but it was a great time. And maybe some of you have used these in your courses here at IST. It was still being used, Nunes, until when?
Still being used.
It's still being used. Okay, great. Not okay. So this was a long time ago, 86. Okay, fast forward, I don't know, 30-something years. This is us in 2016 and 2018. So just to show that we've been collaborating for a long, long time. And that's it. So just some highlights of his successes. So in 2016, he became a fellow of the IEEE for outstanding contributions to image processing and analysis in remote sensing. And he received the first edition of the main Geoscience and Remote Sensing Award. It's called David Landgraf Award. It was given to José in 2017 with a citation for outstanding contributions in the field of remote sensing and image analysis. So it was these two facts really show that he was a very successful researcher in these areas of research. So just a few numbers that summarize his career. So in 2015, 19, 20, and 21, he was a highly cited researcher. I'm sure he will still be in 2022. I'm almost sure the list has not come out yet, but I'm sure he will. He had, not right now, there's still 14. I think he had 17 highly cited papers, which is the highest number ever by any Portuguese scientist in any area of research. He was a distinguished lecturer for the IEEE Geoscience and Remote Sensing Society in 2018. He supervised 20 students, supervised and co-supervised 20 students, which I think is probably the highest number of any professor, at least in our department. I think it is. Not 100% sure, but I think it is. He wrote around 100 journal papers and 200 conference papers. He received several Best Paper Awards, namely from STIE, Remote Sensing Symposium, and 2 Best Paper Awards at GRS, which is the main conference for remote sensing in 2015 and 18. And he was a visiting professor in many different places around Europe, and not only that, he also had a very strong collaboration in China and Hong Kong. But in these places, he spent some relevant time and did some important collaborations. And that's a summary of his, well, bibliometric portrait as of right now. So as of right now, he has like 32,000 citations and age index of 70, which is the largest number in the department by far, but not by far, but by a little. But well, whatever. It's what it is, and it's still growing. So it's still in 2022, of course, it still has like almost 1,200 citations. Okay, so this is like a snapshot of the numbers that describe his career. So it all started a long time ago in this area of remote sensing, which is where I'm going to focus now. It started with José Leitão, who's there, and José Sanguino. And they started working on this meteorological radar system in collaboration with the then called Instituto Nacional de Meteorologia e Geofísica. Now it's called, what is it called now? It's not, it's IPMA, it's something like that, okay? And what they were building is a system to monitor rainfall around the airport and around Lisbon, actually, much higher range. So this could be seen as the root of his work on remote sensing, because this is actually a remote sensing system. But they had to build everything from scratch, from the electronics, even redesigning operating system for the computer to make this work in real time and multitasking. So it was a really multidisciplinary work, but with a sort of a remote sensing goal. Yeah. So this is a copy from a report they wrote at the time. So you can see here, José Bioucas-Dias, José Sanguino, Manuel Bioucas-Dias was a researcher, well, someone who worked at IPMA, and a few other people, and that's the typical image they would produce. So you can see that intensity of rainfall around Lisbon. You can see the map of Portugal. So this is remote sensing in the 90s. Okay, so José obtained his PhDs and master thesis both supervised by Zelitão. His master thesis was about this radar system, and his PhD thesis was like 2 steps ahead in terms of theoretical foundation. So his PhD thesis was about spectral moment estimation, because estimating moments, mean and variance of spectra is a fundamental tool to estimate, say, rain velocity and amounts of rain and stuff like that. So it's a very multidisciplinary work, in fact, because it has computational aspects, conceptual aspects, but also a lot of signal processing theory. It goes all the way from a practical application to theorems. So it's a very deep piece of work. So this is a snapshot of his genealogy. This is actually done by my son for me, but I did it for him because it only changes here. So he was one of the students of José Leitão. The other, I think I didn't forget anyone, was Ana Freire, José Sanguino, Francisco da Silva, Fernando Nunes, sitting there, Cristina Rosa, and myself. And we have very distinguished great-grandfathers and grandfathers. So José Moura is our grandfather. And a few levels up, we have Eddie van Vries, and further a few levels that have Norbert Wiener. Of course, no influence in that. It just happened to be like that. Okay, but I think it's an interesting view. Okay, so this is a snapshot from his first paper on the topics of his thesis. So 1995, which is the year he finished his PhD thesis, it is on, again, as I said, efficient estimation of spectral models. And I highlighted those two yellow sentences because they show that this is the fact that this is a theoretical paper, because it has theoretical results, strong consistency and asymptotic efficiency of some sort of estimator, but it's applied. It's applied to Doppler weather radar. It's not only theory for the sake of itself, it's applied work with a strong theoretical foundation, which is a kind of a hallmark of his work. So this is a few years later. So the second paper that came out of his thesis, it took a couple of years to publish. So this is José in late 90s, and the José and the other José. Also pictures from them. So we have a colleague. We have a colleague with whom we collaborated a lot in the US called Rob Nowak, and he referred to the José the younger and José the older. Like, how are the Josés, the younger and the older? Okay, so next remote sensing related topic on which he worked and on which he supervised one of his first master students, Tiago Silva, was SAR and SAS. So synthetic aperture radar, synthetic aperture sonar, which they started working around 97, something like that. That's the first paper they published on this topic. So in the International Geoscience and Remote Sensing Symposium in 97, and it was about it involves detailed models of propagation in random media. So it's kind of it's not so much of a signal processing paper; it's more of a electromagnetic computation paper, but which is what with Tiago Silva did his master thesis on. Actually, they continued working, and he continued working with different people in this topic of speckling, of denoising SAR images. So SAR images, synthetic aperture radar images, are We have an expert like Paul, an expert on SAR images, are special type of noise, which is very hard to denoise. And so José has been working on this for a long time. So this is a couple of years later, another paper in GARS, also with the Tiago Silva and Tom too. And I also worked with him on this topic. So this is a paper we published in 2010. So it's a long range, it's a long duration research effort on dealing with this type of multiplicative noise images, and using some, in the meantime, new optimization techniques that we were working on at the time. Okay, so another SAR related topic, and maybe I could stop for a while and you can tell us what it is about. We can. So it's Paulo. I think Paulo was José's, if I'm not mistaken, first PhD student. You were? Yes. So he worked essentially on target tracking. So SAR. So one assumption of SAR is that the scene is static. If it's not static, the idea is that maybe you can take advantage of the fact that the targets are moving to estimate things about the target, how it's detection of moving targets, measuring its velocity, and so on. Is that fair? That's a fair assessment. And so these are the two first papers on this topic. These are still conference papers. The national, so the IGARS, IGARS from now on, and the European SAR conference in 2000. So it was 24 years ago, more or less. And they kept on working. And from Paulo's PhD work, if I counted correctly, 12 conference papers and 3 journal papers came out. All of journal papers in IEEE transactions on aerospace and electronic systems, where people publish radar work mostly. And that is Paulo and José in maybe 2005 or something, around that time. Maybe the pictures are a bit older than that. Yeah. That's a tendency, right? And here they are. I don't think so exactly where it is. Maybe at some conference.
No, this was near Park.
Oh, it was here.
It was the cycle.
Yeah. So José was an avid cyclist. And the other guy in the picture is José's older son. Okay. Okay. So another topic related to remote sensing on which José worked a lot in the beginning, also with Tiago Silva, was phase imaging. So phase imaging is just the idea that you can use the phase that comes out of coherent imaging systems, which is in a sense it's a descendant of the work of PhD work of José, which also worked on absolute phase estimation in signals, and in this case it's in images into D. And so José did a lot of work on absolute phase estimation. This is his first paper on this topic, absolute phase estimation with discontinuities. So absolute phase is the idea that you're measuring things that are essentially modulo 2 pi, because that's all you can. When you look at sines and cosines of phases, you don't know if it's 3 pi or 5 pi or whatever number of multiples of pi that you can add to the phase. But if the underlying physical quantity that the phase relates to is not like that, like if it's a height, then you know that you need to estimate the absolute phase, not just phase model 2 pi. And José worked on this topic and published a lot of few papers on this topic, some of them actually very with a lot of impact. So this is one with a nice name, ZPIM, which is a method to do absolute phase estimation for interferometric imaging. So this is called interferometric imaging, and not going to go into the details of this. Actually, I'm going to go a little bit into the details of some part of his work to explain what it is about, which is probably the most successful, but not this one. Okay, so the José student who worked who did this PhD on this topic was Gonçalo Valadão. Maybe it was his second or third PhD student. I don't know if it was before or after José and Chimé. Maybe around the same time. So Gonçalo Valadão worked on this and he did this PhD thesis on this topic of phase estimation. And so this is unwrapping. So this is, you can think of these images of modulo 2 pi, like slices of this image. And the idea is to take these and reconstruct these from as a paper they published on the transactions on image processing in 2007. So José collaborated a lot on phase imaging with other people. That's Vladimir Katkovnik. I think he's attending. Hello, Vladimir, if you're there. I think he's watching. And so José collaborated a lot with Vladimir Katkovnik in around this time, and they published a couple of papers. And Vladimir is a professor at the University of Tampere, and he's a very, very well-known person in the area of several books. Very good collaboration and very good friends. There's someone making sounds. Okay, and this topic of phase imaging kept on being actively explored for a long time. So even recently, this is, I don't know exactly if this is the last one. I think it's the last one. José, who was the main supervisor, Joshin Krishnan, I think is also listening. And so this is something on which I collaborated with them on. Again, in this case, it's phase estimation using some technique. Doesn't really matter. The idea is the same. The idea is that you have phase data. You want to denoise phase data. And it's hard to denoise phase data because of the fact that it's wrapped around these 2 pi loops. And so it kept on going a long time. So this is someone else presenting work on which José collaborated. This is Laurent Jacques from the University of Louvain in Belgium, with whom he also collaborated. We did a long collaboration with these people. So Amir was a PhD student at Louvain, was visiting here for several months, and they had a very fruitful collaboration in this. So structured illumination, which is something that's used in computer vision a lot, is in a sense very related and closely related to phase imaging because of the stripes, the light stripes that illuminate. Okay, so hyperspectral imaging. This is the main, I'd say, the main topic in which José was most successful. He was, probably it's fair to say that he was, or he still is in some sense, the #1 expert in hyperspectral imaging. And that was recognized in different ways. So he started working on hyperspectral imaging in 2003. This is him giving an overview presentation in 2016, as you can see there. And the slide, I will show that picture a little later, explains what hyperspectral imaging is. And fast forward a few years, so 8 years, Whispers, which is the main workshop on hyperspectral imaging, which was organized in Lisbon, and José is there in the center. He was the organizer of the workshop, which shows that in 7 years he became the world leading expert, or one of the world leading experts on hyperspectral imaging. I'm also in the picture, but I'm very far away.
Ouviu perfeitamente a sua preciosa ajuda. Eu ia já escrever uma mensagem, mas entretanto, como estou. Mandou.
Consegues apagar?
Mandou. Estou neste momento a ouvir. Muito obrigada, Emília. Agradeço-lhe imenso. Obrigada.
Okay, sorry. So these 2 people, this is Justin Chanso, this is Antonio Plaza, which are also good friends of José and collaborated a lot with him in this area. So in 7 years, this is what happened. Okay, so hyperspectral imaging. So the first of José's PhD students who worked on hyperspectral imaging was José Nascimento, Jacinto's brother. Jacinto, where are you? There you are. Jacinto's brother, who is now, what is he now right now? President of ISEL. He's president of ISEL. And he did excellent work in his PhD, is like Paul, of course. And these are his first 2 papers, their first 2 papers on hyperspectral imaging, which they were presented at IPRIA, which is a Iberian conference. I actually were there together. José didn't go, but well, this José went, but the older José did not. But I was there for another reason, and we were together. So hyperspectral imaging, just that what I'm going to say next makes any sense. So hyperspectral imaging, the microphone is on. The idea is that what you require in a pixel of an image is not some large typical image, but a spectrum of radiation. So at each pixel you have a spectrum. So you have the intensity of each of different bands of electromagnetic radiation. And the idea is that using these spectra, you can understand what materials are present in the scene. Okay. And this is a very important topic in remote sensing. There are satellites that use these types of cameras. They are expensive. but they provide very, very useful, very important information. So in a nutshell, if you have several in a pixel in one of the regions, if you have different types of materials, the spectrum that you observe is a linear combination of, actually it's a convex combination because the proportions need to sum to 1 of the spectra of the materials. And so by looking at the global spectrum and knowing or not what spectra of the pure materials are, then the goal is to identify the materials in the scene. So we worked a lot on this. This is a picture from one of these reviews papers on this topic. So just to give some technical juice to this talk, I'll talk a little bit about this. So this is the radiance data cube. So this is what thing that's observed by the satellite. And after atmospheric correction, because we need to know what the absorbance is of the atmosphere and what the spectrum of the illuminating radiation is, we have the reflectance data cube, and the reflectance is the reflectance spectrum at each pixel. So each pixel is a spectrum. It has maybe 200 bands or 300 bands. And of course, in these other 2 dimensions, you have space. Okay. And typically, this data is low dimensional because you have a number of different materials in the scene, which is typically much lower than the number of bands that you have in the spectrum, which means that this lives in a lower dimensional space. And one of the things that is very useful to do is dimensionality reduction. And it was actually one of the first topics on which José Manuel worked. So once you have all of these, there are different ways to find these spectra. So if you know the n-number signatures, then you can do something. If you don't, you have to do something else. And there are several ways to do it, which I'll mention briefly next. So mathematical formulations are not very relevant to put it here, but it's just at each pixel you have a convex combination of different spectra, and with this criterion that the weights need to sum to 1 because they're proportions. Essentially, it's just to be written. So pictures are worth 1,000 words. So this is the idea. So this is the idea. Suppose that this is the space. Suppose you have a 3-dimensional spectrum, only 3 bands, 3 pure materials, M1, M2, and M3. And the idea is that any spectrum that you observe should be a convex combination of those 3 pure spectra, or also called pure pixels. And depending on what you know about the scene or you don't, if you know these M's, because you know what the materials that are in the scene, then the problem is easier. If you don't, it's more difficult. Okay. So if you do know, so the first thing that, like I mentioned, should be done is dimensionality reduction, because this is responsible for very strong noise reduction, and it puts the problem in its intrinsic dimensionality. And so the first paper by José Nascimento on this topic and José was this paper on hyperspectral subspace identification, which was a landmark paper in this topic. It has more than 1,000 citations, which is on that particular problem: how to find the dimension of the space in which the data really lives, not the ambient dimension. Okay? And just by doing this, you immediately reduce a lot of the noise that's present in the data, because you're projecting the noise down to a much lower dimension. The signal is in that lower dimension, the noise will take away a lot of the noise that was there. Okay, what about finding these so-called pure spectra that are characteristic of the materials in the scene, the pure materials in the scene? Well, there are different hypotheses, different scenarios. The simplest scenario is if you assume that somewhere in the data there are pure pixels. So if you assume that you're observing a scene, the scene has lots of different materials, but there are some pixels where there's only one material present. Okay? In that case, it's the easiest case. It's called when there are pure pixels present. And this is also one of the topics that José Nascimento addressed in the thesis with José. And they produced this work. This was, again, a landmark paper on this topic called vertex component analysis, or VCA, which it was kind of revolutionized the area at the time. It's José's most cited paper. It's actually the most cited paper ever in these transactions on geoscience and remote sensing. So it's an extremely successful paper. Okay, so the still not too bad, but little not so good scenario is when you don't have pure pixels, but you have some pixels on the facets. What does it mean for a pixel to be on a facet? It means that there are some spectra which have 0 components. Okay? There are no spectra that are pure, but there are some. And in this case, again, it was an initial idea of José and of doing these, which is let's find the simplex, the minimum volume that contains the data. Of course, this is much easier said than done. I'm sweeping under the rug all the technical details, but this is what it is. Okay? So findings called MVSA, minimum volume simplex analysis, and there are many different algorithms to attack this problem. It's a problem of finding how to define the volume of a simplex, how to minimize it, how to add the constraints that the pixels need to all be inside the simplex. So it's a difficult mathematical optimization problem. So the student of José who worked on this topic was Jun Lee. They published several papers on this topic. The one that proposes this key idea, the minimum volume simplex analysis, is this paper from 2015. So Jun Lee is now an IEEE fellow. She was became a very successful researcher, very fast. And there she was in the picture that I showed of the workshop. She was there. Okay, just this is just an illustration of how well this works. Probably I will skip this. So CISAL, MVC, and CISAL. CISAL is the proposed method. Essentially, it shows that as the problem becomes more and more difficult, okay, CISAL still hangs in there, finding the correct n numbers. And in the real difficult case, which is this, when there are nothing that's even close to being pure or being on the facets, CISAL is still working pretty well. And that's it. So another direction, which is even more powerful for difficult situations, is that one that on which José Nascimento worked, also in its thesis, called well, it doesn't have a name. I don't remember the name, but it's based on mixtures of dirichlet components. So essentially, the idea is that is to model these probabilistically, so that this is a random. So the proportions are a random variable. Random variables on a simplex follow this dirichlet distributions. But maybe that's too simplistic, so we have to go one step up and consider mixtures of dirichlet distributions, and that's what they did, and it's a very successful method that works very well, especially for highly mixed situations. So this is a very difficult situation where there are no pixels that even are close to being pure pixels. Okay, the other technique. The next one on the hyperspectral analysis was something called sparse regression, and this is very easy. So this is around the time where sparse regression and sparsity was a very hot topic in signal processing. Sorry. And the idea here is very simple. Maybe I'm taking it a bit too technical, but the idea is that if you have this spectra, okay, each column of this matrix is a spectra, so I have pixels around on the columns. And the idea is that if each of these spectrum is a combination of a few of these, okay, so these are the spectra of a few pixels, then we can write this by saying that each of these columns is a sparse combination of columns of this matrix. And sparsity means that the weights of this combination have mostly zeros and some non-zeros. Okay. This is was a very popular problem at the time in a field called compressive sensing, and this was sort of a translation of compressive sensing ideas to sparse and mixed. So I'm going to skip the details. So we actually wrote together the first efficient algorithm to solve this problem for this application. I didn't work a lot with him on this topic, but we did the first one actually together. And then this was the topic of the PhD topic of Daniel Iordache, who was one of his students, was supervised by Antonio Plaza from the University of Extremadura. So this is 2011 and a few years after this. So they extended this work in many different directions. One called collaborative sparse regression is the idea that, okay, we should try not to have each pixel have its own combination of pure spectra. Maybe all the pixels should decide on what are the materials that are present on the scene, and let's just use those. This is called collaborative sparse regression. It uses different norms, doesn't really matter. So this was the work of Mário and Daniel Iordache that led to his thesis, and there he is in the photo of the okay. So at the time, José was already a leader in this field. So he had proposed PCA and component analysis, the dimensionality reduction approach, the first one, the sparse regression based methods. They were all seminal pieces of work, and so he was really recognized as a leader in the field. And he wrote several review papers with large international teams. So So this is one of review paper on this topic on this IEEE Journal of Selected Topics in Applied Earth Observation and Remote Sensing, long name, with people from different areas. So Antonio Paz is from Spain, from University of Extremadura. Nicolas Lavijon is from Toulouse. Mario Parente is from University of Massachusetts at Amherst. Kim Du is from Mississippi State University. Paul Gather is from University of Florida, and Justin Chanuso is from Grenoble. And so the fact that he is the first author in this paper was very respected. Okay, so this is I think it's José's most cited paper. I think one of the two. It's a very, very highly cited paper from 2012. Okay, so they continued. So this was not the end of the story. They continued. So José continued developing this direction of sparse regression-based methods, most in collaboration with Win-Kim Ma, or Ken Ma, actually that's how his name, who is now the editor-in-chief of the IEEE transactions on signal processing. So Ken Ma is the current serving editor-in-chief of IEEE TSP, and two other people, two other colleagues, one from the University of Hong Kong, actually not at the time he was at the University of Minnesota, and another researcher who was working for the company. And so they extended this idea in two different directions. Actually, this one is to allow for mismatches between what the library is assuming that the computer spectra are and what they actually are. It's a robustification, let's say, of the method. And this one is something called a self-dictionary, which was, again, a topic which was hot in other areas, which is instead of having to have a dictionary of spectra, you can actually take all the spectra and consider them as a dictionary and try to find sparse representation of all the spectra in a few of the others. And the ones that get selected are probably the end members. And this paper has a lot of theory. It has hard to prove theorems that show that solving this self-dictionary sparse regression using linear pursuit is the same thing as searching for few pixels, and it leads to the same result. And so the algorithms are equivalent. This is a hard to read paper. Okay. So this area, this topic of multispectral, hyperspectral analysis was also applied in other areas. So it's remote sensing, not very remote, but it's sensing. It says remote because there's now it's like instead of many kilometers in the sky, we have 2 centimeters away from the sensor. And this idea, but the ideas are exactly the same. So the idea is to have multispectral illumination and sensing of pharmaceutical tablets, to do non-destructive chemical analysis, to see what proportion of different components is present. And this was done in collaboration with GlaxoSmithKline. And this was the PhD work of Marta Lopes, which we co-supervised. So José and myself, we co-supervised on this topic. So the main goal here was to do rapid detection of counterfeit pharmaceuticals in a very fast way, because it doesn't require a full chemical lab to do the chemical analysis. So we published a few papers on this topic, all of them in collaboration with Jean-Claude Wolff from GSK. It's hidden actually here. He's from GlaxoSmithKline in the UK. And this was Martha's PhD thesis was on this topic. So again, multispectral. So still advancing multispectral, hyperspectral analysis. So one thing that all these previous methods do not have is the spatial regularization. The fact that we know that what we're observing is an image, and image have spatial regularity, in the sense that if the proportions of material in a certain area are summed in the neighboring pixel, it's probably very similar, with some exceptions. And so this idea of using spatial regularization, which is present in all of image processing, in all of spatial data sciences, was also imported into this area by José and some collaborators. So this is some solve with TV estimation. As you can see, it's much closer to the ground truth than these two are obtained only on a pixel by pixel way. So by processing pixel by pixel, and these takes not only the information, but also spatial knowledge that spatially the image should be somewhat, at least piecewise smooth. This is also work, not central work, but also work by Mário Bioucas-Dias, which was in the thesis, which was also published in the Transactions on Geoscience and Remote Sensing, 2012. Okay, so all the way to 2019. So remember, maybe some of you remember this idea of trying to do this minimum volume simplex analysis, trying to find the minimum volume simplex that contains all the spectra. And one issue here, fundamental, is that maybe we need to allow some of the, to get a robust method, we need to allow some of the spectra to be outside the simplex. How many? It's kind of a typical problem in regularization. And we collaborated on this work on finding the optimal regularization parameter for minimum volume spectral mixing, which was one of the topics of the PhD thesis of Lina Zwang, finished in 2019. And it's back in China. Another area which is obviously related to this is segmentation. So if you have an image and you want to actually not only find the amount of material in each pixel, but you want to segment in different types of materials, it's not exactly the same as doing hyperspectral mixing, but it's related. It's hyperspectral image segmentation, which was also a topic on which Jun Lee worked. So the same students who worked on the minimum volume simplex analysis. And so this is a paper they published, Transactions on Geoscience and Remote Sensing in 2010 on semi-supervised hyperspectral image segmentation using some technique. Okay, a lot of these works you will see Antonio Plaza here. He was also a close collaborator of José and a friend. He's a professor in Spain. So now I'm leaving a little bit outside of remote sensing, but still staying in imaging. So João Oliveira, he was a student that we co-supervised, who worked on a blur estimation for blind restoration of images. It's just an example that we have, well, this is not a state-of-the-art method anymore. The idea that if you have a blurred image and you want to reconstruct the sharp image, one thing that you need is to know what is the point spread function, what is the impulsive response of the filter. Of course, in real images, you have no idea, so you have to estimate it. And this is real image. This is not a synthetically generated blurred image. It's a real blurred image. And João, who's now a professor at ISCTE, worked on this. This was his thesis was on this topic. Another topic which is closely related to hyperspectral, in this case hyperspectral, but I'll talk about something that's not hyperspectral. Another PhD students of José who worked on hyperspectral problems was Felipe Condessa. This was co-supervised by Jelena Kovacevic, which probably some of you will know who she is. She's a professor at CMU. She was actually, I don't know at the time, but she was president of the department, head of department of the ECE department at Carnegie Mellon. And she was at the time also editor-in-chief of Transactions on Signal Processing many years ago. So Felipe Condessa did his thesis, co-supervised by José and by Jelena on this problem of supervised classification with rejection. So this is a very important topic in classification, which is to design a classifier that is able to say, I don't know. I don't know about that sample, that I will reject. And finally, probably the last topic that I will mention is fusion. This is the one on which I've worked together more closely. This is a summary of what the goal is here. So in pen sharpening or hyperspectral fusion, it goes by many different names. The idea is that you have a multispectral. By multispectral, typically we reserve the word multi for some bands, but not too many. Very high spatial resolution. And you have another type of data which is a lot of bands, but not so high spatial resolution. Because there's a trade-off. Because if you are using very narrow bands, the amount of energy is not so large. And so to keep a constant signal-to-noise ratio, there's a trade-off between spatial resolution and spectral resolution. And you need to trade one for the other. And the idea is to try to do some magic and to fuse the two to obtain data that is simultaneously of high spatial resolution and high spectral resolution. It's called pen sharpening fusion. So this is a good example. So it's a low resolution color image. This is a high resolution monochrome image. And we want to fuse them to make a high resolution color image. And most of the modern cell phone cameras work like this. They have different types of cameras. and it's very computational inside. You don't have a very high resolution color camera full stop, which is a classical mode of imaging. In modern imaging, you tend to have different types of sensors and try to fuse them for different purposes and to co-design the position with the reconstruction. So I'll skip the math. So Miguel Simões was the first PhD student of José who worked on this topic. He was actually co-supervised by our colleague Luís Borges Almeida and by Justine Chamusot, which I mentioned before from Grenoble. And they built the first convex formulation for this problem. So it's important to be convex because from an optimization point of view, it's friendlier. So this is Luís and Justine, or Jocelyn in French. And Miguel Simões was a student who worked on this topic. And we had another student which we co-supervised. So José and myself, Afonso Pedro. He was, I think, the last of PhD student supervised or co-supervised by José. He finished in 2019, and he actually received the IBM scientific prize. I think he was the last IBM scientific prize, but it's over. And we did these several algorithms, several advances in algorithms to address this problem of fusing images. So we did many other things together. As you see, if you look it up, you see we have dozens and dozens of papers co-authored by both of us. This is a paper on optimization for image restoration. Another one which we did in collaboration with Rob Nowak from the University of Wisconsin in Madison, also a good friend of ours, and work on Poissonian imaging. And this shows there's no students. See, there's no student here, and there are no students there. This is work we actually did ourselves: the math, the code, the experiments, everything, and we were already pretty old, late 40s. So we actually worked together and had a lot of active collaboration. We also did this very successful line of work that was carried out by Mani Afonso, a student of ours, who was also at the ISR for a while. I don't think he's there anymore, is he? No, and we wrote this. This was probably the first time that very fashionable optimization technique called DMM was used in these types of problems. And this pair of papers has more than 2,300 citations. Okay, that's it. So I leave you with José's on the clouds. Thank you.
Very nice resume of a very extremely rich scientific class of José. Okay, we have a quite nice piece of audience. We have a remote audience. We have about 45 participants and we about 30. Well, I know José will deserve 700, but it's just a second. But time for.
Of course, I'm happy to take any questions.
Not only questions.
Questions, comments,
testimonies, and so
yes,
I will start by the room. If it was not mine. Someone wants to add something to the.
I want to ask. So of course I know very well these two guys. We finished the same year, so we studied together at the IST. So it's very uncommon to have this pair of close friends that are both so successful at the highest level. Okay, so can I ask you, what do you think was the thing, the moment, the whatever that made you, go to the sky, even individually or together? What was the moment?
I think I have a. I don't know, maybe you don't want to say something about that. I think I'm sort of a. So in the beginning, collaborated in that, as you see, in building that electronic stuff. Then after that, if you see, there's a big gap of time where we didn't collaborate. Started collaborating again, maybe about 2006 or so. So we were both of us pretty competitive, and we kind of had a competitive attitude. Although we were friends, very good friends, but we were professionally and scientifically competitive. And a little bit, of course, if you're competitive against everyone, so you also against your friends. But then around that time, we decided that it is much more fruitful to collaborate than to compete, and so we started collaborating. That was I think that was the click.
It's a win-win.
Yeah.
May I give my testimony because I was with these two guys in dynamic systems, linear dynamic systems course by Isabel today in '86.
Yes.
These guys just finished this ECE course 2 years before.
85.
But by that time, master courses were only starting the year on, year off. So we got together. And the funny thing also for Isabel and for all of us, that we met these two guys and we were discussing and very keen on understanding. It was not precise dynamic systems, their field, because they were starting after they were students at PhD, and they so avid of going into all details, all the deep understanding of what was going on in terms of theorems, in terms of concepts that were introduced. That was something new for me, okay? And so what I realized from that, and also a little bit of the answer for this question that you did, is that 1 + 1 is much more than. And that's something that is stupid at IST, that people close together in each one of these offices thinking that they can fight to the world, doing the best things, and they forget that sometimes the answer to do better work and much more fruitful is just around the corner or just on the nearby room. And that was what I had the chance of seeing in my eyes during lots and lots of years, because we had lots of lunch together after these courses and that. And they were always very keen on discussing the topics to the essence and understanding the same. And that was the beautiful of that.
That's a good point.
Do you mind to ask the people? I'm not sure if they are here.
If anyone wants to ask any question, please feel free and mute yourself, comments, testimony, anything you want to say. Just say your name and I will stop sharing to see if there's anyone here.
Maria, could I say a couple of words?
Who is speaking? Vladimir?
Yes.
Yes. Hello,
Yes,
Vladimir. How are you? Good to hear you.
I'm fine, thank you. So my name is Vladimir Katkovnik. I am from Tampere University, Finland. Do you hear me?
Yes, I'll
Okay. So,
wait a second.
No.
Wait a second. Why isn't this? Yeah. Just a second.
some problems with sound.
No. Okay. Okay. It's maximum. Okay, you can go ahead. Go ahead.
Okay. Okay, my name is
I will
Vladimir.
repeat the question here if we don't hear.
Yes. My name is Vladimir Katkovnik. I'm from Tampere University, Finland. We've been happy to collaborate with José. Actually, we started to work together in 2014. It was around face imaging problem, and I visited Lisbon twice, and José also visited our place twice, and he actually liked our lakes, our university. But what I can say, it was actually exceptionally nice work and very nice communication. I would say José was very gifted man, not only as a scientist, but as a person. So, when Mario, you told that he had 20 PhD students, I understand why it's so much, because he was he liked people. He actually was able to communicate, and it was very productive in this communication. So I would say we were so happy, and that we actually were in the line of collaborators with José. And also I wish to say, Mario, you presented very nice talk and highlighted many things unknown for us. So thank you very much. Okay.
Thank you, Vladimir.
That's all what I wish to say.
Thank you, Vladimir.
you.
Nice to hear you. Nice to know
Okay.
from you.
Thank you.
Anyone else wants to say something? Anna.
Add something. I think it's obvious from all the publications how amazing the work, scientific work that Mario
Right.
and the collaboration with the Bioucas has done. But I would like also to emphasize that he was a remarkable person, not only from the scientific point of view, but as a person and as a friend. And that does not show in the papers.
I will say just a few words. I'm, in fact, much older than José and Mario. There's one thing which is remarkable. Whenever I touched his door, it had some probably silly question, was always there. Have a patient tell me exactly the answer for a question that could be far from his field, but he could point me in the right direction. So as a person, 5 stars, I don't know if it's enough.
After José, I have again one question. José.
It's a wonderful testimony. Just like to share that. So I was a PhD student more or less at the same time. So we shared place, especially nights and camps.
Yes.
And I remember so I was a few times from the camps. So one that happened a few times was late night, and we were trying to finish a paper for some conference deadline probably in a few hours. I remember you and so you were coming back from yet another revision from supervisor. And basically it was a riot from all over the table. It was very all over. And we were desperate. I think it was a very fantastic exercise, discussing all the time and trying to reach the perfection, but really to the and I learned a lot through you. The other thing I think he was a very curious person. Just to raise a question that immediately was and he was generous because I remember when it was such problems I was trying to address, and if I mentioned this to him, then he immediately start discussing and trying to. It's always a very passionate discussion. Also at the department level, and both.
Maria Manso, can
Emília, quer dizer
Yes,
alguma coisa?
I'm here. I would like to say that I had it was very good to work with José Bioucas, not for a long time because he had no time for us, but I knew him since he was a student. He worked at Complex Interdisciplinar, and I remember very well one night he used to work very late, that he fall in a hole, and the other day he was all covered with patches in his head, but still working. I remember the excellent person he was, and the good colleague, always trying to help with a low profile, but with great knowledge, and we miss him very much. Thank you, Mario, for reminding us José Bioucas.
Thank you. What's it? What?
Okay. First of all,
Then sit down.
for a very nice presentation. And first, I'd like to say a few words about especially one that I have to both to Mario and Sergio.
guys, they collaborate with some of my course, junior assistants. There's one special that we say without I pointed my year that I came back from the US. I had developed an interesting stochastic process. It was a long process for me. It's a long time to understand, and then I thought so simple. This can be together in a simple way, and it can open new paths. It was all together. I'll offer a course in stochastic foundation of truth. And it was like almost like a singularity. So not the person you drop, but was with three people. It was Mário Bioucas-Dias and the third person that sometime one or other people also went through. And we covered very extensive breadth of theory, serious stuff to study, measuring protection theory, and then the thread foundations. And I mean, those guys were, it was really a pleasure. Always on there because working hard, we had regular problem sets that were difficult with, I mean, and it was really a pleasure to, that was one of the high points of my professional.
One of the high points of my learning during life. Yeah, well,
Oh, without.
I'm sorry for wearing this, but for people in my group, in fact, it's just to keep you safe. My first real work closely with José Bioucas was when I was when I had the hard work of being president of the department, and we had to do a self-evaluation exercise. I wouldn't have done it without José. I mean, he was extremely helpful, but also kept us in the right track because it was such a difficult exercise, and I could see how this guy got where he was because he was brilliant, even in doing a stuff like that. And then I have to say that I miss great lunches at Complex. I mean, the food was not great, but the company made up for it. It was excellent. I'll never forget this. I miss him terribly.
Just to say a few words, I was the first PhD student of Bioucas, and I already met him before starting. And I can say that besides being a wonderful scientist, he was also a very good engineer, one of the best engineers I met until today. So he was able to discuss everything from theoretical point of view to practical point of view, that's implementation. You could talk with him about anything, and also about the person, which I emphasized here. I can say it was one of the best human beings I met. So it was really emotional because I was really fan of Bioucas. Sorry for this, but was one of the best persons that I met until today. So I wanted to say this because, in fact, he was very supportive in a very hard situation I had in life, and he was there. He was my professor, but was also my friend, and I'm grateful for that.
Thank you. Okay. Let me just tell one word about the scientific part of José Bioucas' work. I would say that is regarding the hyperspectral algorithms that they presented. I think, in my opinion, they will become each time more important and they will be, and he will be more suited as the hyperspectral sensors are becoming each time more accessible, portable, and less expensive. It's incredible, the evolution. So we'll hear José Bioucas for a long time. And all those out there. So
Let me just
yes.
add something about the early story of José, which is probably not known by everybody. He did not have an easy beginning in life.
Mhm.
So he didn't go to high school like most of us. He went to Escola Industrial. And when we were coming to Técnico to become students, he was working at Timigal at 18, right? And then after working at Timigal for 2 years as a electrotechnical technician, I don't know what's called that. He decided that he wanted to become an engineer, and then he came to Técnico. That's why we are contemporary in terms of academics, but he is 2 years older than me, and the same people. And he always made fun of everybody else because when we were learning electrotechnics of the Electrotecnia Teórica with some people back there. And you say, I've seen cosine of phi in person. And you have not. You said, you guys don't have, so this is what before we take those courses. In Portuguese, it's much funnier. I know, eu sei o que é o cosseno de phi, vocês não fazem isso.
Okay, time to close the section. Let's thank again, Mário. Just one more thing. This the recording of this section will be available in YouTube. I will let you know through your department. Okay, thank you all.
Thank you.